Hello, everyone. I hope you're having a great day. I wanted to give you a quick video to do a couple of extra examples with our double angle identities. So we covered these in class. These are how you find the sine, cosine, and tangent of twice an angle that you have. Um, so we've kind of gone over some of these, and we did these first couple of examples. I wanted to go through number 2 with you. So you had another example of this one with the variable in it. So we're trying to evaluate this expression. Your answer should contain v's, which is your variable, but it should not contain any trig functions at the end. Um, and I'm going to tell you this on a test. Alex doesn't include it, but just for your benefit, it's going to be easiest to just assume that your variable is positive. It's just going to make your life a lot easier. Um, so just assume that variable is positive. Okay, so let's try number 2 here. We want to evaluate the cosine of 2 times the arc cosine of 6v. So this is a parallel parking example, right? We have a forward trig function on the outside and a backwards trig function on the inside. So we're going to have to parallel park here. And the way that we do these problems is you start on the inside and you work your way out. So if we start on the very inside of here, the first thing that we're going to do is have to do this inverse cosine of 6v. So this is a reverse trig function. So what that means is that this 6v, that is our cosine ratio. So that's not opposite, that's, sorry, 6v over 1. This is a cosine ratio, so it's adjacent over hypotenuse. There we go. So we're given a ratio, an inverse cosine is going to go backwards and take us back to the angle that has this ratio. So we're going to get an angle out of this. The problem is 6v definitely does not live on the unit circle. But it is a ratio, so we can draw a triangle for this. So we'll get there. But the first thing that we're going to do is just kind of note to ourselves that, oh, I'm going to do inverse cosine of 6v and I'm going to get an angle out. I'm going to name this angle theta for right now. I don't know exactly what that angle is going to be. It's okay. We're not going to have to find it. So theta is going to be the inverse cosine of 6v. It's going to be the angle that has a cosine value of 6v over 1. And so basically, once we have this angle theta out of inverse cosine of 6v, we would then, to finish this problem, we would have to do the cosine of 2 times that angle theta. Well, the cosine of 2 times that angle theta, I know how to do that. In order to find that, I'm going to come to my double angle identities and I'm going to use one of these guys. To find the cosine of 2 theta, you can use any of the 3 of these forms. You can choose the form that is the most convenient for you. So for instance, here in what I'm given, I have the cosine value of theta already, right? Because inverse cosine is going to give me the angle theta that has a cosine value of 6v over 1. So I know that the cosine of theta is going to be 6v over 1. So I'm going to make my life easier here, and I'm going to pick the form here that has the cosine value in it and only the cosine value. You can pick one of the other two as well, and I'll show you how to do that in a minute. But I'm going to pick this one and work a little bit, kind of take the path of least resistance. So I'm going to use this middle one here, 2 cosine squared of theta minus 1. This is the formula that I'm going to use to find the cosine of 2 theta. And in order to do that, I'm going to do 2, and then I'm going to multiply that by the cosine of theta squared. I know the cosine of theta without even drawing a triangle. I know that the angle that I get out of here is going to have a cosine value of 6v over 1. So 6v is going to be my cosine value. I can just pop that in. I don't even have to draw a triangle for this one. So here's my cosine value. I'm going to square it, and I'm going to subtract 1. And so now we just have to do the arithmetic here. Order of operations says we got to do the exponent first. So I'm going to do 2 times 6v is 36v squared. And then I'm going to do the multiplication here. So that's going to be 72v squared minus 1. I can't combine anymore, so that is our answer. This is the cosine of 2 times the inverse cosine of 6v. So this one is, if you choose your formula correctly, you won't even have to draw a triangle for it. But if you choose one of the other ones that has a sine of theta in it, then in order to complete that, we'll just draw a triangle to find other trig values of theta. I want to kind of show you that so you have that in your arsenal as well. So if I had to find the other trig values, because theta is the inverse cosine of 6v, and I'm assuming v is positive here, that means this ratio of 6 times v, that's also going to be positive. Because I have a positive ratio inside inverse cosine is going to take me to an angle that lives in quadrant 1, because a positive ratio takes me back to quadrant 1. So I'm going to draw a triangle in quadrant 1. Here is that angle theta that inverse cosine is going to give me. I don't know what it is, but that's okay. But what I do know is that the cosine value adjacent over hypotenuse is 6v over 1. So my adjacent side is 6v. My hypotenuse is 1. And, excuse me, if you call this opposite side y, in order to solve for this, we'll do the Pythagorean theorem. So a squared plus b squared equals c squared. And this is what we're solving for here. So we'll have 36v squared plus y squared equals 1. Solving for y, that means y squared equals 1 minus 36v squared. You'll take the square root of both sides, and that means y is plus or minus the square root of 1 minus 36v squared. And if I come back to my triangle here, because my y value is positive in quadrant 1, this is going to be the positive square root of 1 minus 36v squared. That's a v. And you can use this triangle to get your other trig values if you need it to do one of these problems. So you can choose the formula that's most convenient for you with the information that you're given, so you won't even have to draw a triangle, or you can draw a triangle and get the information that you need to do any of them. Okay, so that's how we do those, guys. And again, the kicker here is just label this inverse cosine value or whatever inverse trig function you have in here, label it with an angle, and then plug that angle here in so that you know how to get your formula. That's kind of the hard bit about this. Okay, and I wanted to go through these examples down here with you as well. These aren't going to feel quite as I guess, new and different and that kind of thing. This is going to feel very similar to what we did with some indifference formulas. So we want to use a double angle identity to simplify each expression. So we want to simplify cosine squared of 15 degrees minus sine squared of 15 degrees. And we're told to use a double angle identity here. So I'm going to go back to my double angle identities, and I'm going to look for something that looks like this. Cosine squared of an angle minus sine squared of an angle. That's what I'm looking for in my double angle identities, so I can figure out what to apply here. So cosine squared of an angle minus sine squared of an angle. Let's go up and see what we can find. Cosine squared of an angle minus sine squared of an angle. It's right here. This matches the structure of what I'm given. I've got cosine squared of an angle minus sine squared of an angle. That means I can use this identity and go backwards, and I can replace what I'm given with cosine of 2 times that angle. So what I'm given here is the same as the cosine of 2 times my angle. And my angle here is 15 degrees. And so that means that what I'm given is the cosine of 2 times 15 degrees. 2 times 15 degrees is 30 degrees. So this whole thing is the cosine of 30 degrees. That's on the unit circle. I can find an exact value for that. 30 degrees is over here somewhere. That's not perfect, but that's okay. 30 degrees. My ordered pair at 30 degrees is root 3. That's a 3 over 2, 1/2, which means the cosine value of 30 degrees is my x coordinate here, which is root 3 over 2. So the cosine squared of 15 degrees minus sine squared of 15 degrees is root 3 over 2. So this is very similar to what we did before. You're going to look for the structure of what you're given inside your trig functions so you know what to apply. Let's try number 2 here. We have the sine of an angle times the cosine of an angle. Let's see if we can find that in our double angles. So sine of an angle times cosine of an angle. Do you see sine of an angle times cosine of an angle in here? Oh, it's right here, I see. So sine of an angle times cosine of an angle is right here. Okay, so this is what I'm given. Now, the weird thing here is that I don't have this 2. I'm missing that. So what I'm going to do is I'm going to rearrange this identity a little bit to make it work for me in the situation that I'm in. So I want to figure out what just sine of an angle times cosine of an angle looks like. So to get this thing by itself, I'm going to divide both sides by 2 here. I'm going to divide this side by 2, and I'm going to divide this side by 2. So when I do that, on the left, I get the sine of 2x divided by 2. I'm going to write that as 1/2 times the sine of 2x. My brain likes that better, but if you like this as sine of 2x over 2, you can absolutely do that. And then on the other side, those 2's are going to cancel, and I'm going to get the sine of x times the cosine of x over here. And so now that I have this rearranged, this is what I'm given in the structure of the problem. This matches my structure, and so now I know what to replace that with. So I'm going to replace what I have with 1/2 times the sine of twice my angle. So if I come back down here, I'm going to replace this with 1/2 times the sine of 2 times my angle. And my angle here is pi over 8. Okay, so, well, we used our double angle identity. Now we have to figure out what this is. Okay, so this is going to be 1/2 times the sine of 2 times pi over 8. That's 2 over 1 times pi over 8. That's 2 pi over 8, or pi over 4. I'm just going to go ahead and simplify that. 2 pi over 8 is pi over 4. Take a 2 out of top and bottom. And so now I have 1/2 times the sine of pi over 4. The sine of pi over 4 is on the unit circle. We know how to evaluate that. And this is one of the ones where x and y match. So both x and y are root 2 over 2 on the unit circle. So the sine of pi over 4 is root 2 over 2. And so now I can multiply across to multiply that by 1/2. 1 times root 2 is root 2. And on the bottom, 2 times 2 is 4. There's no simplification I can do here, so I'm going to have to leave that as root 2 over 4. But that is the value of the sine of pi over 8 times the cosine of pi over 8. So hopefully that helps you with these problems. Again, look for the structure of what you have inside your identities, and don't be afraid to rearrange to make these identities work for you. If you're missing something, or if it's not exactly in the right form, feel free to move some things around in those identities and resolve them so that you can see exactly what you have so that you know what to replace it with and you can use the identity accurately. So I hope that helps. Have a great day, and I will see you in class tomorrow.